tidy and like lots of tiny errors, like .html is not the same as HTML. It's picky about brackets, all sorts of other things. Okay. So that link is not currently active, but I'll make the link active so you can check. Last bit is about sum. So we can build more complex models than the ones we've just did. And actually, you can also build multi-level models with structured equation models. They're quite similar because they're all equations. But I just wanted to show an example of how to do this, and this is based on the Wheaton database. And he also used longitudinal data to study alienation as a function of socioeconomic status and anomie. You know what anomie is? It's like not having morals. So each of the three factors, so in this one, we can actually take what we've taken from last week, like factor analysis, and we can combine it with some type of mediation analysis to build a model. So that's quite neat. So it also means that you can use structured equation models for longitudinal data, because we can explicitly model correlations between time 1 and time 2, and we can say, let those be correlated. So he captured data from a survey in 1966 and 1971, and you can read more about that paper in detail. And we don't need the raw data to do that actually. So if you have somebody's correlation matrix or covariance matrix, and you know the number of observations, you can build a model. So this is the covariance matrix. It's just printed like that, and we can convert that via getCov into a matrix which Lavant can then use. So we just attach the names to this matrix. So we just have the under half of the matrix with the variance or the correlations, and we can turn that into a data set to model with. So we have anomie, powerlessness, anomie 71, powerlessness in 71, education, and socioeconomic status based on occupation. This is an SEE type of index. Not sure how readable that is, but that's the model we're trying to get at. So it's alienation 67 predicts alienation 71, and socioeconomic status is in the middle, explaining both paths. And these two are measured via anomie and powerlessness. They're making this alienation construct, 66 and 71. Yeah. So it's trying to see if alienation in time 1 predicts time 2, accounting for socioeconomic status. Yeah. So this model brings together which type of things from SEM. I've already given away confirmatory factor analysis as well as mediation testing, all together in one giant model. So this type of model, we can write out the measurement model and the structure model. So the measurement model are all the factors, so those things. So SES, which is education plus SEE. Alienation is anomie and powerlessness. We have that for 67 for 71. And then those are the relationship between those things, those arrows we've seen drawn. And then what we also want is correlated residual. So we want 67 to relate to 71 for anomie, and we want powerlessness from 67 to relate to 71 to account for the fact that there's temporal trends. So if people are already on the up, they will also be on the up 5 years later, or if they're already going down, they're already going down 5 years later. So to account for temporal structures, we allow for correlations. So those will be double-headed arrows. An indirect effect via SAS is just nothing more than this mediation type of thing, which we've also defined in previous models. So that's that model that we've just saw, that complex thing, written into equations, which we can then solve, and then we can put numbers to all those arrows that we want to explain. So something is missing from the graph. What is missing from the graph? What we have in our model? So this maps on quite well to the structured equation model, but something is missing. No? So it's what we've not drawn here is a correlated residual. So we've not drawn here that anomie of 67 is related to anomie of 71. So normally we would draw a double-headed arrow here, and here in this drawing there's no double-headed arrows between those two and between those two. Yeah? So that's where the graph doesn't map on to the actual model. And we do that to account for the fact that time things are correlated, so that 67 is correlated to 71, and so that if people's response of how powerlessness they were in 66. Now that's related to 71 because it's the same question. It's to allow for that correspondence over time. We can then actually run the model, and we'll print massive output again. And just to show you that it works, I'll just show you that, and then we're done. Oh, that's a blank one. And here's the one. So, we can already see that we're quite happy because of these CFI and TLI things, which should be close to 1. So, if you want, you can also have p-values based on the chi-square statistics, and that's the one where you don't want it to be significant. We have the AIC-BC if we want to compare different models. And if we go further down, we'll also have RMSEA, which should be below 0.05. And that's a very good model, which we would love because it's below 0.05. And the 95 confidence interval just touches 0.05, but it's if we do a p-value, it's not significantly different from 0.05. So what we then can print is all the different estimates. All the different estimates for all those arrows, for all those latent variables. So we have latent variables, those ellipticals, and then we have regressions, the arrows going from from those latents to the other one. So, and also from going from alienation to SES, for example. We can have those arrows, and then this is the bit. Sorry, it's inversed. So this is where we explicitly modeled the fact that 67 for one time point correlates to 71 for another time point for anomie for powerlessness, and we should do that at least for anomia because that's a significant covariance. And then these are all the variants, and this is the indirect effect of those arrows that we defined, which is significantly different from 0. So hooray for that model because it's showing that pathway. I think we should quit here, but I'll just show you that you can also plot it and make a nice little figure from it. And you can also then look at it on your thing, so we can make a nice graph from this. So this is education SE rate leading to SES, alienation for 67, alienation for 71. Those are the correlated residuals. That's the indirect effect. So SES predicts this, predicts that, and that's the mediation type of pathway which we have going on. That's all I had in mind, and you can try it yourself by removing an arrow, and then I have an exercise for you to try and build a structured equation model. So have a go at doing the exercises, and see you again next week for multi-level models. And have a go at doing the dplyr exercise, and I'll post the result.